Okay, so this is just a introduction to cadCAD and the Commons and how the Commons Stack uses cadCAD. The Commons Stack's mission is to create sustainable funding solutions for the provision of public goods. We do this through incentive alignment and integrating coordination techniques so that we can improve the current situation for the nonprofit and government space. The nonprofits and governments are generally the solution to public goods, and we want to build a foundation of tooling and documentation for these same organizations that are already trying to provide public goods for society, give them another alternative to the existing nonprofit and governmental solutions. This is the problem with our current economy. Our current economy just sucks. I'm going to straight up say it. Like there's a huge problem for the people who are producing value in a community and for a community. Generally, I feel personally that the economy's purpose is to reward people who are producing value. Money should be happiness points. And if you're creating happiness, whether it's for a community or for an individual, you should be receiving happiness points. This is the game of our economy. This is what I would like the game for our economy to be. And I think generally the Commons Stack team feels the same way. Currently, nonprofits are a horrible fit for the current economies that we have, and they have a few major problems. Number one, they rely on self-sacrifice. Number two, the decision makers don't have a good incentive system to create metrics and understand whether or not they're doing a good job and when they're making decisions. There's just very few feedback mechanisms. And of course, it's generally underfunded. It has a lot of problems finding continuous funding streams. Whereas for-profits that are producing value for individuals have no problems on these issues. And but they do have a problem in that they're incentivized to evade taxes and exploit externalities because those are not generally represented in the economy. So what we want to do is create a new option for all the people that are trying to create public goods for their communities. We believe that there is magic in the blockchain approach, that the blockchains have actually solved the tragedy of commons by designing economies that have aligned incentives to match the production of the shared resource that they want to produce. This is how blockchains have kind of done it. You can, if you put on your commons perspective, you can see most blockchains actually are providing an aligned incentive for the production of a shared resource. And whether it's Prime Coin just finding prime numbers for the world, or if it's CureCoin folding proteins for cancer research, they're using the block reward to provide computing power for a computing power commons. Now, the Commons Stack goal is to take this magic, this blockchain incentive alignment power that exists in creating your own blockchain-based economy or crypto, using crypto economics, and to apply it to real-world applications. The real-world application I want to focus on today is for helping the homeless population in Denver, but this can be very broadly applied, and the Commons Stack hopes to build a foundation that can be applied for almost anything, even outside of the nonprofit space. So the way that we do this is you can imagine the already existing economy in the homeless aid sector in Denver, right? There are people in Denver that are, and all around the world, that are donating money to nonprofits that help the homeless. Inside of those nonprofits, there are decision makers. And these decision makers have to spend that money on supporting the homeless population. Now, money just flows in and it flows out, and the decision makers have to make their best guess on on satisfying the donors, because of course they're the income stream that they need to keep happy, and of course actually being effective at producing value for the homeless community of Denver. What we do to enable an even stronger application of homeless aid for Denver is we wrap that existing economy in a bonding curve. And the bonding curve, and I should probably explain a little bit more about how bonding curves work. I'll do that in the next slide. But the bonding curve creates a situation where donors end up receiving a token in return, and that token helps align their incentives, where instead of having self-sacrifice and just donating out of the kindness of their heart, then they get something in return that then gives them an incentive to grow this internal economy. And because the internal economy is wrapped in the bonding curve, we can create a circular economy that can then be measured and managed more appropriately. And one of the coolest things, I think, is in the power of decentralization and allowing those who contribute resources to the internal economy to have a distributed stake in the actual decisions that are made, because the token holders are and become the decision makers. So the way it works is basically someone will, once it's been launched, if someone wants to donate to a homeless shelter, they have the choice of either donating directly to the shelter, or if they hear about this sheltering Denver Commons, they can send their money directly to this to the shelter effectively by actually sending their money to the Commons and then using the tokens that they receive in return back to vote for this homeless shelter that they wanted to send money to anyway. So in this way, they're incentivized because it's almost like a lossless donation, right? They get to allocate the money that's already in the economy based off of how much money they've put in. So they put in $100, they get $100 back. And this is all, magic based off of the bonding curve. And the bonding curve is really, really powerful because it is for microeconomies to have liquidity in their token. If you're at all familiar with crypto, you know that there are huge liquidity issues, especially in small market cap coins. The value will fluctuate erratically based off of who happens to be trading, what whales come in and what whales come out. With a bonding curve, and we use this a specially designed bonding curve called the Augmented bonding curve, you can deterministically set the price for each token that exists in the economy. So instead of a normal two-sided marketplace where if you want to buy tokens, someone has to sell them, and if you want to sell tokens, someone has to buy them, here we have a smart contract that holds collateral. And whenever you want to buy tokens, you go to the smart contract and you say, hey, send me $100 worth of tokens. And $100 worth of tokens is created for you based off of the price that the bonding curve sets for those tokens in advance. And then if you want to sell your tokens, again, you don't have to find someone to buy them. You can actually just go to the smart contract and have tokens and destroy your tokens. And this is really powerful because that means if the sheltering Denver Commons doesn't work out, all the tokens can be sold and collateral can be returned to the users that were participating in the first place. Or if it gets huge, you don't have these crazy shocks to the price because tokens can be created to supply the demand. Now, what we do to pool funds in the sheltering Denver Commons is when someone sends in $100, of course, that $100 needs to be converted to DAI and then sent to the Commons. They receive $100 back. But to incentivize people to maintain their funds in the internal economy of the sheltering Denver Commons, when they send $100 worth of tokens to the Commons, they only receive $80 in return. And this incentivizes people to grow the internal economy. And we call this feature the exit tribute. And all funds in the exit tribute end up going to the funding pool. So the Sheltering Denver Commons within it has two pools of money. There is the reserve, which holds the collateral that backs the actual economy. And there's the funding pool, which holds the funds that are meant to be spent on supporting the homeless community in Denver. This relationship between the reserve and the funding pool is really easy to simulate and design using cadCAD because we have limited the external connections from the outside world, and we can model the agent's behavior. So the exact dynamics between these two pools ends up being, it can be unique to every commons. But what is the same for every commons is that the funds that pool in the funding pool are decided to be on how they are spent using our conviction voting governance methodology, which allows very simple and easy UX for communities. Oh, I'm getting feedback. It's mute. Thank you. So if someone conviction voting makes it really easy for token holders to make their own individual decisions and then aggregate those signals into a result of funding different projects within that support the homeless community in Denver. And it's a governance method that was built from first principles specifically for this application. Now, what is magical is the power to simulate an economy like this. In our normal economies, we don't actually have a lot of value for economic simulations. This is because in the legacy economic world, we have a completely open system where anyone can do anything, but you have a regulatory commission or enforcement agency that says you can't do X, Y, and Z. But of course you actually can, you just don't want to get caught, otherwise there's punishment. So this creates a very difficult situation for modeling because the behavior is so unrestricted. When you use a crypto economy, there is no regulatory agency. There's just code. And all the actions that are allowed in that code, all of the functions, can be described mathematically. They can only call those functions. So we have a limited set of behaviors that are possible. And but in a normal crypto economy, you still have this issue where you don't know how much money you're going to get for your tokens. And you don't know how your behaviors will change the price for everybody else because there's such a huge variable in the amount of liquidity in that secondary market. So if you have a token bonding curve that's actually designed specifically for connecting the price to agent behaviors. For instance, unfortunately, the bonding curve that Oregon has with the TAP doesn't quite meet this criteria, but with a couple of tweaks, it could, and you could completely map every agent's behavior and every action an agent can take to the final price after they take that action. Now, this gets really interesting because in the legacy economy, for instance, Jeff Bezos, he's got $130 billion of Amazon stock, but we don't actually know how much that stock would be worth if he sold it all right now. It's very much dependent on how the market would react to it. And also, we don't know what the final price of that Amazon token would be. Amazon share. However, with an augmented bonding curve, we can actually say, oh yeah, you have 16% of all Amazon bonding curve tokens in existence. Well, this is worth this much. Yes, you have a market cap value, but that's actually an illusion. The real value is X. And that's because the price is algorithmic. And so if we can start making simulations where the price changes after every agent's behavior that will affect the price, we can start better predicting how the behavior of these agents will change over time in a dynamic system. And this is the power of cadCAD. When connected to an economy that is designed specifically for creating a system like this, we can actually have what we call token physics, where you can design economies like people design buildings. Just an aside, my sister is actually an architectural engineer, and when she works on designing buildings, they actually design a weak point, and they know if there's a catastrophic earthquake, then this is the place where the building will fail. And then they build a whole system around, okay, if this fails, this is what will keep the building standing for as long as possible. And if you can actually use design economies like people design buildings, we can really have an impact on how these economies react to catastrophic failure. I mean, I think this is just incredible. So, but to design these systems, it takes a lot of work. And this is the magic of cadCAD, though, because cadCAD is completely open source. So if the common stack goes through all of this groundwork, and we produce a mathematical model that is simulated and optimized with better behavior over time, people can just take our model and make a couple tweaks to customize it for their own economy. And we want to make that really easy for people. And then they can have the same results with very little work, because this is the magic of open source, of course. Work can be easily shared. So our design is basically to use cadCAD to create these modules that can be plugged together. And we don't want to create them all just ourselves. We want to enable the community to create as many of these modules together and almost act like librarians, that people can use different books off the shelf, different modules that have been created, and plug them together and do their cadCAD designs and optimize them for their community, and then produce the commons with as little effort as possible. Now, to do this effectively, unfortunately, we have to keep things very simple. This is a design requirement, so there's lots of features that would make the sheltering commons more effective. Maybe an entry tribute would be useful. Maybe if people donated directly to the funding pool, they would get voting tokens that, you know, have more power but can't be returned for money. Maybe, maybe there's a vesting period that is variable based off of what the price of the token is. There's so many really cool features that we would like to include. However, this makes everything more complicated. And I'll show you why. So like in a very simple system, for starting these commons, we have a community of experts, ideally that have the altruistic values of their goal isn't to make money, their goal is to help the homeless in the Denver community. They pool their funds together and they hatch the commons. And once their funds get converted to DAI and actually go to the Sheltering Denver Commons, they get split between the reserve and the funding pool. And then everybody receives tokens in return. Now, what's really cool about this is because of this market cap illusion, the hatchers end up with more token value than money they put in, at least on paper, on Etherscan, right? But in the end, if they sold all of their tokens, there's less money than they originally put in the reserve than there is in the funding pool. Well, than what they put in total, because some of it was donated to the funding pool and will go to help shelter the homeless in Denver. And so we've aligned the incentives where the hatchers end up with more tokens that represent more money than they put in, because in a token bonding curve, you have an under collateralized token. And so that means that there may be $3 million worth of token for only $1 million that were put into reserve. But at the same time, the hatchers are still properly incentivized, because if they just sold all of their tokens, they would lose the money that was donated to the funding pool. And what's really cool about this incentive model is that basically the punishment is what exists already in the nonprofit world. When you donate, you get nothing in return. But so the punishment is just going back to normal donations. The reward can be, if you create a stable economy, then you are rewarded for your efforts and making the good decisions that have brought more people and to care about the homeless situation in Denver. Now, if it was just like this, if it was just a simple, money comes in, it's split between two pools of money and tokens are created, then, then we would have a design like this. So this is kind of a whiteboard of that graph that I just showed, where the green represents tokens and the blue represents DAI, where when funds come in, it's the hatch tribute, which is the percentage of money that goes to the funding pool that the hatchers donate. That money is split between those two pools, and then tokens are created. However, this situation is not a good idea because of the under-collateralization of a token bonding curve. You end up with a situation where the original donors would be incentivized just to sell their tokens right away and kind of screw everybody else that holds the tokens. And that's not a design we want. We don't want to be tempting people's altruism. We want to design a system that enables altruistic people to make a huge impact. And so we include a vesting policy. And just adding that vesting policy, you can see how much more complications it adds to the system. And so every feature that you add creates more complications. So our goal in the Common Stack is to create the minimum viable system that will result in a very powerful outcome for communities that can then be iterated on by everybody else. Now, to use cadCAD and to design things, it's important that you start with the math and the whiteboard. You need to understand what you're designing before you throw it in cadCAD. So a lot of the time, I've seen developers in the crypto space actually work on projects. They go straight to the code. They start writing the functions that they want, and they write comments that describe the function's behavior, and then they start, building those functions. At least this is how Jordi Ballina does it. When I've seen him build projects for Giveth, and but that's not the way that you want to do engineering work when it's difficult to change things at the end. It's actually really valuable to have full whiteboard designs and describe it in math when you're using cadCAD. So this is our full system. This is the math for just the hatch of our system. It's a little more complicated than it says because it's also integrating the initiation of the bonding curve. And you can see, I just want to pull out the power function invariant shape. This equation is a constant. V with RS in parentheses is just a large number, a constant, that represents the ratio between the token supply and the amount of funds in the reserve. And the token supply is held to a power of kappa. And that ratio is an invariant. It becomes like a law of physics for our system. And it's important to have these laws within our system so that we can design token physical systems. This is the whole system whiteboarded. You can see the augmented bonding curve. Money here is moving around in DAI. I'm a little behind, so I don't want to go into this. But you can see we're trying to simplify, and this is a little bit more simplified than some of the features that are there. For instance, the trigger valve, and we just put a box there that's like the conditional logic that makes funds from the funding pool, that counts the conviction voting, voting power for each individual agent in the system, and then aggregates that to algorithmically decide which proposals get funded. We just put a box there. It's a little more complicated than just a box. But it's important to have this and the math before you start really going into cadCAD. And then to kind of create a map that will help with debugging your complex system, you can start mapping things into into this kind of system where you have the behaviors, basically the actions that will be taken and that you want to map out. So like, okay, a voter makes a choice. And then because of that voter choice, that user behavior, then what mechanisms are triggered after that user makes that choice? And then once what states of the system are changed by the mechanisms that were triggered by that behavior. And this system evolves based off of the state, right? And so we can have a state update that is consistent with agent behaviors. And this map specifically is really powerful for debugging processes in cadCAD. I don't know, is Hobbit there? If Hobbit's there and has anything to add to this conversation, I'd be open to letting you speak. Are you there, Hobbit?
Hey there.
Hey.
Everything is fine. I think the presentation is going on, and I think that you are saying everything that the people needs to know right now.
Okay. Well, that's miraculous. Thanks, Hobbit, for the confidence booster. Okay, so let's actually look at a cadCAD model. If you don't have the slides yet, if someone has the slides and can post this link in Telegram, that would be great. Because this is actually a Google Colab. Google Colab is a very powerful tool for using cadCAD. What's one of the hacks of Google Colab is that you can actually, if you look at this is actually just a link to a GitHub simulation that was built. So you can even just import a simulation that is already posted on cadCAD. A cadCAD simulation that's already posted on GitHub, and boom, it just works in your Google Colab. The only thing that you have to do is you have to add a line, and it should really be before this. I'll just add it in here. That says pip install cadCAD. Let me make sure that I didn't make a typo there. Uh-oh. Spoiler alert. Okay, pip install cadCAD. Oh boy, I'm excited for that slide. So now that we have this, we can go here and just, well, I'm not going to run all because it's already here and it takes time. But you can see here, this is where we define the invariant that I described before, which is S to the kappa over R. This is the token supply over the reserve. And we define other laws of physics that we implemented into our simulation. And then we get all these graphs. And what's amazing is, you know, if you wanted to, you could just take this, make a couple little tweaks, change the amount of dye that ends up being donated in advance, or change the prices that we put out, or you know, maybe you want to create some extra feature that makes, like I said, adds a vesting period to anyone who donates. That's a variable. Like you can just make little tweaks in already existing simulations, and all of these cool graphs that someone already put in for you just appear. You can also do parameter sweeps and optimizations for that work for the behavior of the agents that you believe will be using your system, not for the agents that are using this system, because maybe this is the token engineering commons, which will have a very different set of behavior than people who are working in the sheltering Denver commons. And we can reuse everybody's work and just iterate and get things better and better. And this is what's really exciting about cadCAD. And one thing that I think people also haven't really been able to chew on yet is what happens after you're done with the design. These cadCAD models are incredibly powerful for optimizing and parameterizing the behaviors of your system before it gets launched. But after it's launched, if it matches the deployment, now you have this system that can be even further optimized and improved by Like, okay, the system is running, people are starting to take actions, everything's on the blockchain, so you can start mapping those actions to results and behaviors and improving your cadCAD model. And once your cadCAD model now matches the actual behaviors and of the system that we are experiencing, and now we have a tool that can be used for computer-aided governance that can actually do predictive modeling on governance decisions and feature upgrades that you want to propose for your system, but you don't know how they're actually going to react with the complex system that you've deployed. So now we can actually, like, could you imagine if MakerDAO had a simulation tool, and which I believe they actually did work with BlockScience a little bit to create this, that could help them optimize and predict the correct proposals for changing the interest rate of their system. And then not only for their system, but if Compound and Curve Finance and all the other DeFi projects also had a cadCAD model that could all be plugged together, then we could see the complex changes that will occur to all of these other systems that by simulating what will happen if MakerDAO decides to up the interest rate to 15% and changes the DAI savings rate to 3%. We can model that behavior, and if these cadCAD models are well adapted to the actual system that's deployed, then we can project how these systems will behave under these governance decisions. This is fucking futuristic shit, okay? This is wild. Once we start adding machine learning tools and other, buzzwords around AI, this can really make a huge change in the world that we live if we start designing economies using these tools. So the Common Stack's main goal is to use the application of cadCAD and support the application of cadCAD to forward nonprofit and public causes that support public goods. We're doing this through the help of a trusted seed. If you guys have any interest in supporting our work and contributing to cadCAD, because we really want to take cadCAD under our wing, about somewhere around 25 to 30% of all the funds that we project to raise, especially in the beginning. I think for our first iteration, it's about 45% of the funds will go to supporting cadCAD and developing this software so it can be better utilized by the crypto community as a whole. And but to do this, we do need to raise funds, but we're not just doing an open raise. We're actually committed to, as Lorelei said, we stalk people who apply to our trusted seed and confirm that they're coming in with the right behaviors, because there will be opportunities to make money with the Common Stack, but that's not our primary objective. Our goal is to align incentives, and it's much easier to do that with altruistic people who come in with the right attitude, and let the investors that just want to make profits come in when the systems are ready for that. So if you want to contribute to the Common Stack, please click apply. And right now, this link is broken for the Brave browser and some mobile devices. Just a problem between Typeform and Brave. So open the link in Google Chrome, or I think Firefox works, and apply, and then we can see if we can accept your financial contributions. But the other ways, of course, if you're a developer, join our dev channel. Our goal is not to have a dev team. We want to decentralize our dev team so that we don't have a major centralization point that we've seen in other blockchain projects, that it's like you have this technocracy where the devs make all the rules. And so we're trying to have a decentralized dev team. Please join our Telegram channel. And if you want to participate and learn more about cadCAD, they also have a community channel and a community forum. There's a lot of links here as well if you want to learn more about our community, or read some blog posts that I pulled out that I think especially apply to what I talked about. And we also we produce academic papers. And of course, our cadCAD models are very easy and accessible to play with. But yeah, well, does anyone have any quick questions on my presentation? Good, because I want to get. Oh, go ahead.
I just wanted to say you dropped the F-bombs and the swear words at the right time. You kept me.
Oh, thanks, Jeff. I have this horrible habit of feeling when people will be disengaged and then swearing to like pique their interest. It's a bad habit, but I'll work on it.
No. It was exciting stuff. It was a really good underline of the point to be made. Go cadCAD.
Yeah.
Go token engineering.
Yeah, thanks, man. Well, then, with no further ado, I want to give the floor to Hobbit. There's some links in the slideshow that will be useful, specifically the Robots and Marbles tutorial link and a link to Google Colab, a fresh Google Colab. And if you guys can get those links, I don't know if someone would be an angel and post those links in Jitsi and in the main Telegram group. That would be amazing. And let's get this show on the road. The floor is yours, Hobbit.
So, hi guys. My name is Danilo, and I am a research engineer here at BlockScience. And on this workshop, we will show you how to use cadCAD for doing some very simple models, but also by explaining the concepts behind it. So I hope that after that workshop, you can start developing some simple models, and if possible, even deviate from them. Actually, we reserved the last 15 minutes just to you show anything fun that you have done. And I will send on the chat of this video conference a link for a collab for the first tutorial, which is the tutorial that we will walk you all very carefully. Pasting it. Where is the chat here?
Do you want to share your screen, Danilo?
Yeah. Oh, yeah. I'm just searching for the button here. It disappeared.
It's to the bottom left.
Wait a moment here. Yeah, Jitsi has disappeared with the button, with the screen sharing button.
Oh, maybe the screen share.
Okay, appeared again.
Yeah.
So,
thank you, Gus, for posting that link. Praise.
Okay, I will pass the link here on the chat. Actually, I'm posting the Robot and Marbles link one. It is already on Colab, and actually it opens the GitHub notebook that there is in the cadCAD repository. And the intent of this tutorial is to introduce the most basic things that you need to actually run a cadCAD model. So, cadCAD depends on several concepts to get it running. It uses the concepts of state variables, time steps, state update functions, and part of state update blocks. Before I explain it, there is a image that I like it a lot that explains the overall workings of cadCAD. And this is the picture. It is a bit confusing maybe, but I will try to explain it briefly. Basically, cadCAD has an state with several variables, and those variables can be anything. They can be concrete objects like numbers and strings, but they can be also classes and more abstract objects. And what cadCAD does is that for each time step, which is this head block, which represents a timing, some point in time, like, for example, today or tomorrow. For each time, you have these several blocks, which are the partial state update blocks. And they represent, let's say, sets of things happening. So for the first partial state update block, for example, you have a series of policies. Policies represent laws of nature or laws of nature. They represent laws that do transformations to the state variables. And they happen everything at once. They happen simultaneously. And once they happen, they all got aggregate together. They can be not cadCAD by default. It sums the results of the policies, but you can configure that. We can enter in that later. And once you update a variable, there is a conversion function that picks the result of these laws and updates the state. And when this happens, you have another partial state update block, which you can have different laws. So for each time, you have different sets of laws happening at the same time. And cadCAD works by simulating this process as many times you like. And you can put in stochastic models. You can use different parameters. In a brief, this is what cadCAD does. And in this tutorial, we will explore some of these things in a simpler way. So, in this tutorial here, in the first one, we will enunciate the basic structure of cadCAD. So first, you always have initial conditions, which represents the state at time 0. It represents basically in this picture, the state here at the beginning, where nothing happened. This is the initial conditions. And here you declare the variables and what values they take, which can be numbers, can be objects, anything as you would like. And after that, another important function, another thing is that you have the state updation functions, which is these things. What happens in the presence of policies or even in the absence? They always happen and they update the variables.
And just really quick, Danilo, I just want to give a chance. Is anyone in this audience familiar with cadCAD? Has anyone built, has anyone done the Robots and Marbles tutorial themselves? If anyone has, just speak up.
I did actually.
Some did. Who is that? Was that Lior?
No, sorry, that wasn't me. No, if you ask me, I mean, at least in my case, I'm very beginning, but I don't want to. Like,
okay, that's great. I just wanted to check in and see how if anyone else has done this already, and if not, then if it's just Sam, then I feel like we should. I would suggest that it's really fun to actually start with a blank cadCAD and just start copying and pasting these lines in and build your own simulation.
Yeah, so we start for blank 10.
But I mean, I think Hobbit, Danilo, if you want, you don't have to, but you can see each of these lines are really easy to copy and paste in, and then you can feel the creation of your simulation.
Yeah. This is just a brief introduction, but we can try to create something. Well, I will just finish to explain something of the things here for about 3 minutes. Then we can try to do something from blank. I think that it's the most logical.
Okay.
But well, on this tutorial, what it does is simply that. You don't have any policies. You have some state updation functions that picks the state, and it simply updates, adds to 1 or subtracts 1 depending on the value of the states. It's very simple, and this is just essential to having something running. Well, you have the link. I think that you can see the basic structure from there, but we can try to build something new, for example.
Yeah, and just a little background, this simulation is very simple. It's just you have this robot arm that has 2 boxes, and it moves marbles from one box to the other based off of the rule that you put in place. So
Yeah.
Right now, the rule that we put in place is, hey, make the boxes even. And so a robot arm just moves 1 marble from one box to the box that has less marbles.
So when we create a blank new notebook, I think the most obvious thing is to install cadCAD. And as we install, it's I think that I always think that it is useful is to think into what variables the state contains. And I think that the initial conditions dictionary, they always serves as a guide of what we want to model. So just putting a trick here so there won't be any message here. So when I design a cadCAD model, I always begin, for example, with defining the initial conditions because it defines the state. A model that I like a lot is the prey-predator model. I can try to do that. So we can say about, I don't know, prey population. And we could say that it begins with, let's say, 100 preys. And we also have predators. And they begin with, let's say, 10 predators. Another, I always like to have the Robot Marbles tutorial opened right beside because it always serves to remember me of the logical steps that I must take. So if I have prey and predators variables, I need to update them. So I can define something like, for example, update prey function. And also update predator. And here I copy and paste the parameters to have some logical steps. I'm just doing some model that it's going outside my mind, but you can do as you wish. You can, as I typed in, you can do whatever you want, and I think it would even be interesting if you show anything that you have done.
Yeah, if you're a developer, feel free to go wild.
Yeah,
and if
go wild.
If you're not, just copy and paste. And
Yeah.
you can just copy and paste from the Robots and Marbles tutorial as it shows.
Yeah, so here I remove the logic because I will use some policies. So you can put here update. The inner workings of the update function works as like that. The first, you have to return a tuple, and the first element is the variable that you are updating, the variable that you have put here in the initial conditions, and the second one will be the value of that. But at the same time, you have to define X.
And X is the resulting state, or it's how the state changes?
X is the value that the variable is going to take. So X in this case must be input. And it will be a thing that the policy returns. I will put anything here, but we will define afterwards. So what is sales? You have the state of the functions which have input, the prey pop and the predator pop. And the update function gets this number and sums it up with the current state of the population. So if it is a positive number, then the number goes up. And if it is a negative number, it goes down for the next state. And as I wrote a state updating function, I always find it useful to already pick up create the partial state update blocks definition here. So I'll put here the format of these partial state update blocks. They always need to have the policies and the variables case, but also you have to specify the name of the variables that it's going to update. Well, with the policies, you have a bit more flexibility about that. Now we can create some policies actually. So here is the part that we actually get creative. So there, I will pick up another tutorial here to always have side-by-side model, which is here in the part 2. I do that because sometimes to copy-paste the structure is more quicker than typing it entirely. So the definition of this policy stat is just like the state update function, but you don't have the input because the structure of the input, the output is a bit different. A policy, when the keys and values that you put here, they go up to the input dictionary. So when you trigger a policy, you can trigger several state policies at once. But of course, they all got aggregate. So if two policies update the same variable, these two inputs get summed before getting to the state updating function. So we can think in several policies for a prey-predator model. For example, we can be thinking about, let's say, prey birds. And the only output that it does have is about the prey pop. I will just put a placeholder here. But at the same time, we don't need to implement everything at once. We can think in abstract and think, for example, that we need to have also predator birds policy, and also a prey deaths, and also predator deaths. And we can think what causes them to give birth or to die. So, for example, prey birds, I can assume that they are just a factor of their own population. Every step they reproduce about 20%. So we can think in this way: previous population equals state at the moment of the prey population. And the newborn ones is 20% of this population. So we can pick the previous population and multiply for 0.2. And we can return pre-pop equals newborn ones. And when it comes to predator birds, we can think in another way because the predators feed on the prey. So we can think something like, for example, you have the prey population, which is S prey population, and you have a predator population. And how does this interaction occur? There is several ways that you can think about it. You can think that the predator birds is a function both of the predator population, the prey, or just the predator. The beauty of cadCAD is that you can experiment a lot of that. You can think in several ways on how you can copy that and do experiments about that and see how it goes. But I can postulate, for example, that I don't know why I will put that, but let's say we can put in something like that. And we can think about prey deaths. We can think that they only die because of the predator. So we can put something similar to that. However, with a different factor, and we can toy with that afterwards.
Just a quick question. Newborns ones is a local variable?
Yeah, they're all local.
Okay.
I will put here a minus sign to signal that they are subtracting. And for predator deaths, we can put a decay factor. So we sort of copy and paste here. However, with a minus sign. Actually, I don't know what we are going to that. I'm just picking this model from my mind. Let's hope that it works.
Amazing, man. Amazing. I can't believe you're just making this up on the fly.
Yeah, so I will put a -1 here that I think that it's a bit clearer. So we have now 4 policy functions. You can toy with that as you want. You can put all your factors you want. There's a lot of variations that you can do. Actually, I don't know even if that is going to work. I just pick up this from my mind. And also, I think that we need to put here is to declare the policy. So we have the prey birds, which is equal prey birds. And we have the predator birds, and also prey deaths. Oh, I forgot to. It's also useful to separate the update state functions and the So everything that we wrote until now is just definitions. It's just a recipe for cadCAD for interpreting and doing things with that. But now that we have...
So wait, the policies, is that the right place where the policies start?
You can put everywhere because what
Because-
we are doing here is just writing the structure and the logic that cadCAD will do.
So I'm
We-
just curious why prey births is a state update function and predator births is a policy.
Oh, I got it wrong here. Actually, I've put the... okay, now it's right.
Okay.
So now everything is right, and we can try to run cadCAD. So I will copy and paste the simulation parameters. It's always easier to have something besides you. And for example, T here you controls how much time steps we will run. As this is a simple model, we can, let's go for 1,000. And now we have all the blocks that we need. So we import here the cadCAD configuration generator. And as I copy paste it run.
And what's great about Google Colab is Google servers are the ones that you're using to run cadCAD. So,
Yeah.
you know, go to town. Monte
Exactly.
Carlo, time steps,
Yeah.
it's not your problem. It's Google.
Now,
Google.
yeah. Now it's going to be the moment of truth. If he is going to throw an error, you throw it now. Let's say if it goes true. Oops. Let's see what I've done here. Okay. Just a typing error. Okay, I think now it's right. Oh, well, let's see what we got. So the output of cadCAD was going to be this run result. Run result is basically in a nutshell, is a thing that you always going to be consumed via Panda. So I import here. And let's see what we got.
Pandas is a graphing generation Python package that's very popular. In general, cadCAD's amazing if you're a well-rounded Python dev. You have you know what to do. But Pandas is the default that everyone seems to use for making cool graphs.
The cadCAD part was until this part here on the block that I select, until the run result. This is the cadCAD part that involves modeling, having have to define the configurations and parameters. When you get to this step, it's when you go beyond cadCAD and enters into data analysis and data science realm. So we have here a Pandas data frame, so we can do now some plots. For example, the classical way to represent that is to pick, let's say, the prey population as a certain axis and the predator population as another. And try to plot it and see if it, oops. And plot them together, one against the other, and see if you can, see if there is anything cool about, oops. Oh yeah, I forgot to. Okay, I didn't like the simulation. But the thing is, but the thing about this model is that when you select some set of parameters, you have a very interesting cycle. Let me try to remember what I need to change. I think that this must be smaller, and I think it is even more. Maybe if I change here.
You have to rerun cadCAD. You didn't.
Run all.
No, I don't need. I just need to update the policies functions that when I run F3 again, it will resimulate it. Okay, I don't know the magic parameters. Actually, I will do a cheating because I've already done this model some time ago, and I think that I have here.
Cheater.
it's always hard to note the parameters on the fly. So sometimes it's one of the reasons why you must have some extensive study stage just to have a bounds of what parameters can be realistic. This is one of the first models that I've done on cadCAD, actually. It's basically very similar to what I showed you. However, the parameters here are right. I can even share with you afterwards if you want.
What's that?
Yeah.
Is it a
So my feedback as a person that understands very little in code, I think that the syntax here is pretty much readable. I will thankful. I will thank only more comments, you know, in which the specific functions and set of codes are doing. I mean, in a later phase when I go through tutorials, in this specific part, I'm loving this new tool by Google, by the way. That just, I mean, it's simple to understand, so that's an opportunity to explain things with just comments on code. This is what I'm thinking at the moment.
Yeah. I think that comments is a very important section, and actually, when I have a little more of time developing, I always have the practice, for example, to put a doc string here and say, let's say, I can put something like, for example, the Volterra love for. But actually, this happens when we have a little more time, because comments they always need to be well thought of, as well as the code. This let's say,
In the robots and marbles tutorial, which I encourage you guys to start, it's very well commented and made for
exactly.
this. So feel free to get started on it while we continue finishing the predator-prey discussion.
Yeah, the tutorials in cadCAD, they have abundance of comments, and they have a lot of pictures.
Yeah, do you want to describe that predator-prey graph really quick though, because it's really cool. The little it like spirals out of control. It looks like. Oh, I see. You're cheating and adding it to your current model. Ooh, some derivatives. Well, yeah, guys, get started on the robots and marbles tutorial. And if you guys have any issue, you can either just, if it's quiet, just feel free to speak up. If someone else is talking, there's a little, on the bottom left, there's a raise hand button. Just click that and I'll make sure, I'll moderate the discussion and make sure that we come to you next. But feel free to dive in and start with, I would suggest starting with a fresh cadCAD Google Colab sheet and just follow the robots and marbles tutorial, starting at part 1, copy and pasting each thing, and you can just kind of skim through the document and see what pieces you want to learn. And go at your own speed. And Sam, if you want to, hack on like the conviction CV3 model for Commons Simulator, which is a project that anyone, if you really want to dive into cadCAD, we do need cadCAD help on. So if you really are excited about this and want to learn while also producing real value, you're more than welcome to contribute to that. And we also will reward people with the DAI we raised during our Gitcoin grant for their work. So the Commons Simulator is not a volunteer effort. You feel free to learn on and get paid a little bit while you do it. But yeah, so we're here to answer questions and just get started. And yeah, the tutorial that takes you from zero coding to a level where you can simulate a network is exactly the robots and marbles tutorial. I think by part 5, you're creating a network of people interacting with each other, or robot arms connecting to each other.
All right, I have a meeting in a few minutes, so I'm gonna have to leave the call, but thank you very, very much for both the presentation and the quick demo. I'm actually starting to do the marble demo tutorial. I'm going to finish it probably like tomorrow or next, but I'll ask you guys if I have any question, probably in Telegram.
Cool. Yeah, I'll stay on for another 20 or so minutes and help you guys at least get started on the robots and marbles tutorial. Thanks, Hobbit, Danilo. You go by Hobbit too, right? Uh-oh, I hope so. Oh, you're muted. You're muted, Hobbit. Or at least we can't hear you. Not sure what happened. Maybe plug and replug the headphones or something, because we can't hear you. Sometimes the headphone jack screws things up. No, still we can't hear you. Try refresh. Oh, we lost him. Well, I'm just gonna show how to get started. I'm gonna go to the slides. So first, you want to go to Robots and Marbles 1. And you can just kind of read the tutorial. A lot of it's stuff we already covered. And then just copy this. Let's do a new notebook. Google has really endeared themselves to me by creating this free resource. You just always want to start with this. And then a new code line. That. And then, of course, reading this tutorial. And then, oh, line 2. Okay. Right? And of course, spend more time than I am right now. Uh-oh, make sure you select the whole thing. You can spend more time trying to figure out, oh, okay, it's moving from box A to, if box A is bigger than box B, then subtract 1 from box A. You know, if box A is less than box B, add 1 to box B. Okay, that all makes sense. let's just add this in. And, you know, I like to hit run all once in a while just to get things going, see if I somehow made an error somewhere. And then you just, ooh, pretty drawings. Okay, this is like a fake out. Don't copy paste that. Oh, here's the copy paste action. We are building the partial state update. Oh man, I keep not selecting the top line. Good thing I'm watching for that. And this, I like this plus code button because it allows you to execute each one of these individually and judge whether or not you are making a mistake, whether it's a copy paste error or maybe there's even a mistake in the tutorial. Random people like myself go in there and try to add GitHub comments, so add comments on GitHub, and I don't know what I'm doing, so sometimes I might break things. Let's see. So yeah, that's basically how things go. Make sure that there's no one with questions. So I'm just going to sit here, and silence is perfectly fine. I hope you guys are actually hacking on this Robots and Marbles tutorial or something related to cadCAD, and if you run into something, I'm excited to answer your questions.
Thank you, Griff. It was cool. Yeah, and I was just following what you were doing. Yeah, well, I will have to read the tutorial to realize what I have to do next.
Yeah, well, there's no questions. I'll just start doing the tutorial in a very lazy, not learning way, because I've already done this tutorial. So I'm just going to start doing the copy paste game. Ooh. Ooh.
Griff, after step number 7, you're supposed to run something, or you're still copy and pasting?
After step 7, this is line 7. Yeah, you keep copy and pasting, and you know, it's I run almost every time I copy and paste as a way to just check to make sure that I didn't make a mistake, a copy paste error. And it's really quick to either use the keyboard shortcut or just click run all. But once you hit step 7, you have an output. So it is a great idea to run something and make sure your output matches what is here. And step 8 shows that output graphically, which is basically, oh look, robot arm every step moves one ball from box A to box B. And you see the numbers converge to 5, and then the robot arm stops working. And once you get to in step 10, then or sorry, in step 9, you change and you give it an odd number of. You start with an odd number of marbles in box A, and then you plot the results, and you see that you get 6565. And then when you do that graphically, you see that the robot arm doesn't stop moving, which is interesting, right? And this is mostly to show how important initial conditions are to any kind of system, whether it's simple or complex. But especially in complex systems, initial conditions really change the outcome of any system. So once you've done part 1, you can move to part 2. You can see, uh-oh, my last update, I broke it, but then it got fixed. I hope. Okay. So I actually just start a fresh Google Colab every time. Oh, interesting. Because it's in my drive, I don't have to do this? That's amazing. I don't know. Don't trust me on this. I'm not a developer. I'm just pretending here. Look, I made that note. So proud. And if you want to be cool, you know, all of this is just from part 1. It's just being restated. So you can even stay in your previous thing. I actually, just to be safe, always start a new one because sometimes there are little slight differences. And you know, one thing that we didn't talk about is the simulation parameters. They are explained later, but it's really powerful to be able to just up the number of time steps by adding a 0, or to be able to do a Monte Carlo simulation where you do more simulations than just one. You can simulate it. Once you start adding randomness, you can really start seeing many outcomes, 1,000 outcomes that are possible. Maybe even if you decide to really kill Google's servers, you could do 1 million. And it's just by adding a 0 there. And then M is actually for parameter sweeps, I believe. And it's also a very powerful tool. cadCAD is really just made, as far as I can tell, to simulate crypto economic systems. So it's really the perfect tool for the blockchain space. Oh, see, I didn't run all of it. Ooh, see, look, this is what it looks like when you have 100 steps. Let's change that back.
Hey.
Well, great, guys. I want to give you guys a heads up that there's also a Robots and Marbles video that can give you some more background that BlockScience has produced. And as well as there is in these slides, you have links to our simulations, you have links to our communities, blog posts, academic papers that have been written about this. And most importantly, if you guys have any cadCAD issues, you're more than welcome to join our dev channel and ask there. Or if it's really cadCAD specific, join the open CAD public Telegram group for cadCAD and ask questions there. They are begging for people to use this tool and support people because they put countless hours into creating this beautiful resource for the crypto community that we can start doing robust engineering work, token engineering, and really validate our designs before they get out there. And then also validate later the changes, the governance changes that we decide to implement, and confirm that with our estimation of how the system behaves and our modelings, that we make good governance decisions. For me, this is the beginning of something huge. And I really appreciate the people who came to check it out. Thank you all for coming, and we'll see you on the flip side.
Cool. Great.